Okay, dear students, we are in Eamcet Mathematics and we have started matrices. Two classes we have finished up to question number 10. See, this is the third class for matrices. We will do from question number 11 to 15 in this class. Okay. See, this is asked in Eamcet 1992. 2-3 questions we will do on trace concept. Trace. What is trace? See, to understand the trace, one thing you remember, you see, A, B, C, D. This is a matrix. You see, concept is left to right, top to bottom. LRTB, like that you remember. That means diagonal. Left to right you have to go, but top to bottom you have to come. That means AD. Here A plus D is the trace. Okay. A plus D is the trace. If it is a three or third order matrices, means like that you have to take it. That means diagonal. Normally here CB and AD both are diagonal, but which is trace diagonal? How you are going to know? Left to right, top to bottom. Left to right. That means you see A to B you have to go, but A to D you have to come. Top to bottom. This is called trace. Okay. Now let us go back to the question. See, question what they asked, the traces of A and B, here two traces are there. For matrix A, one trace, for matrix 2, another trace. For matrix A, trace is 20, for matrix B, trace is -8. Then what is the trace of A plus B, like they are asking? See, simply, trace of A plus B is equal to trace of A plus trace of B. Right now, trace of A plus B is equal to trace of A plus trace of B. Okay? Trace of A plus trace of B. What is trace of A? 20 plus -8. 12. That means trace of A plus B is 12. This is the answer. Let us go for 12th question. Okay, see question number 12. Let A is equal to 7548, B is equal to 4375 and C is equal to -537 -4. These three are matrices. If you observe carefully, these are 2 by 2, 2 by 2, that means square matrices. Okay. If TRS denotes trace of a square matrix, yes, then see from K 0 to infinity, sigma 1 by 3 power k into trace of A into BC is equal to, BC whole power k is equal to how much, like they are asking. You see, simply what you have to do, B into C you have to multiply, power k you have to apply, afterwards again you have to multiply with A, that matrix, complete this matrix, trace you have to take. That trace divided by 3 power k. Every time you have to apply. K should be 0, k should be 1, k should be up to infinity. It is like a infinite series. Even though they have given in Eamcet, but this is like we can say up to JEE main level question. This is okay. Let us see how to proceed and how to tackle this question. Observe carefully. Okay, see, step by step I am doing. Observe carefully. First of all, I want to do B into C. Okay, see what I am doing. BC is equal to 4375 into, okay, into -537 -4. Okay. See how we are going to do multiplication. Because BC means B into C. Okay. See, 4 into -5 -20, 3 into 7 +21. Okay. 4 into 3 12, 3 into -4 -12, 7 into -5 -35, 5 into 7 +35, 7 into 3 21, 5 into 4 -20. Okay. Then what is the final what we can say result of this matrix? See, -20 plus 21 1, 12 minus 12 0, -35 plus 35 0, 21 minus 21. That means see, this is I. I means we know very well property. A into I is equal to A. That we know. A into I. See, I power something also I only will come. I into I into I into k times you are going to multiply, but even then I only will come. Let us write. BC power k is equal to I power k, that is equal to I. Okay, we know very well. Afterwards, comma A into BC power k is equal to A into I, that is equal to A. Then finally what will happen? A into BC power k under brace is equal to A, that is equal to, what is A? 7548. 7548. Okay? Yes. See, we have got up to here, but trace we have not yet seen. Go for trace also. See what I am doing? Trace of A, BC whole power k is equal to 7 plus 8, 15. Okay? Okay, now go for this. Complete. Then what will be the sigma k is equal to 0 to infinity 1 by 3 power k into trace of this entire thing. A, B, C whole power k implies I have kept. Why? Because see, I have to write a series. See what will happen. First I will take k as 0. K as 0 means 3 power 0. You see what I am writing? 1 by 3 power 0 into trace of AB. You see this trace of ABC whole power k is constant. 15, 15, 15 only will come. Okay, that is not going to change. 15 plus next time 3 power 1 you have to apply. Why? Because from 0 to infinity. 15 by 3 power 1 plus 15 by 3 power 2 plus 15 by, shall I write this 15 by 3 power 0? Okay? 15 by 3 power 0. Okay? 15 by 3 cube plus up to infinity times. Okay? Is this okay? Yes, correct. Now stop and analyze. What is this? This is a geometric progression infinite series. How we are telling geometric series? You see 15 by 3 divided by 15 by 1. This is 15 by 1. 3 power 0 is 1. Okay? See what I am writing. Say this is, write down. This is GP infinite series. Infinite series. Okay? Infinite series. Infinite series formula we know, but before that we will write something. Okay, see here. A will be 15 by 1. Why? Because 3 power 0 is something 1. 15 by 1 means 15. Okay, A will be okay. Now, what will be R? See, second term divided by first term. That means see 15 by 3 divided by means into 3 power 0 by 15. Shall I do like this? Definitely. 15, 15 you cancel out. 1 by 3 will be your R. 3 power 0 is 1, 1 by 3. See, can you check again this also? 15 by 9 by. Yes, we can check. You see, 15 by 9 into 3 by 15. Okay? 15, 15 going to get cancelled out 3 1 times, 3 3 times. That is equal to 1 by 3. That means what we have to understand here? A is 15, R is 1 by 3. This is a infinite series. What is the formula for infinite series? Geometric progression. You see, sum S is equal to A by 1 minus R. That's all. A is how much? 15. Write down. By 1 minus R. R is how much? 1 by 3. 3 minus 1. 2 by 3. 15 by 2 by 3. That is equal to 45 by 2 will be your answer. Okay? Let us go for 13th question. Okay, see question number 13. The real part of, see this is not a matrix, this is a determinant. Okay, see we know very well matrices itself determinants are mixed. cos alpha plus I sin alpha, determinant of cos alpha plus I sin alpha, cos beta plus I sin beta plus I cos beta, sin alpha plus I cos alpha. Observe carefully, alpha, alpha, beta, 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 alpha, alpha is there, sin cos, cos sin cos, like that they are there. What they are asking, see determinant you have to find, and the real part of this determinant what is like they are asking. See delta you have to find, that's all. Delta if you find, automatically final answer will come. Final answer will be in two component form. Real part and imaginary part will be there. Then let us see what will happen. Okay, see determinant how you are going to find AD minus BC, that's all. Okay, I need not tell you, determinant is equal to AD minus BC. That means see AD minus BC. Okay, that is equal to, you see what I am writing, AD minus BC means see cos alpha plus I sin alpha, write down cos alpha plus I sin alpha into D, this one, sin alpha plus I cos alpha minus BC. B is how much? Cos beta plus I sin beta into C, sin beta plus I cos beta. Okay. See, this is not a tough question, but this is what we can say laborious question. You have to do mistakes, occurrence is there, possibility of mistake occurrence. That is why you should be very careful. You see, cos you have to multiply, afterwards I sin you have to multiply. See what I am doing now. Cos alpha sin alpha, write down cos alpha sin alpha, then plus I, okay, cos alpha cos square alpha, okay, with cos over, see plus I sin alpha plus I sin alpha, that means I sin square alpha, see plus I square, sin alpha cos alpha. Okay. Now you put parenthesis and apply minus. Why? Because minus is there. Apply minus and another parenthesis you keep. Why? Because no not required any bracket. Parenthesis itself you can. Cos beta sin beta plus I cos square beta plus I sin square beta plus I square sin beta cos beta. Okay. Okay. Now proceed further then. You see, I square value is minus 1. Okay. That we know. Cos alpha sin alpha minus sin alpha cos alpha. Sin alpha cos alpha. Put parenthesis. Plus I, okay, I am taking common plus I, sin square alpha plus cos square alpha. Okay, okay. Now put minus again, this minus, put another parenthesis, and here also see I square means minus 1, minus sin beta cos beta, write down cos beta sin beta minus sin beta cos beta. Okay, this is the real part. Then go for imaginary. Plus I cos square beta sin square beta sin square beta cos square beta, sin square beta plus cos square beta, like this you can write. Okay, see what will happen here. Both are same. You see sin alpha cos alpha, sin alpha cos alpha. That means this real part is 0 first. Plus I sin square alpha plus cos square alpha is 1 minus this real part also, you see sin beta cos beta minus 0 plus I sin square beta plus cos square beta is 1. Finally what is here? That means real part is 0, imaginary part also I minus I, 0. That implies 0 plus I 0. Now what is the real part? You tell me. Real part is 0, imaginary part is 0. Both are 0. That means you can write 0 as answer. Okay. Let us go for 14th question. See 14th question. The sum of the values of x so that the matrix, see matrix sum A, B they have given, but this is I. Okay, A, I, but in between x is multiplying. A minus xi, like you can take. This matrix is singular, like they are telling. What is singular? Singularity means determinant should be equal to 0. Okay, I am writing here, you see. Singularity means determinant should be equal to 0. Okay, that is called singular. Okay, now first of all you find this final matrix. Why? Because multiply with x, then finally you find one matrix. That matrix you have to take as a determinant and find the determinant, equate it to 0. That is called singular. Okay. At the time equation form it is going to come. Why? Because in x form it is there, naturally it will be coming in equation form. That equation form, it may be quadratic, it may be linear, it may be cubic. You have to solve for x values. See, sum of all values you have to add. Sum of means you have to add all values of x. If it is cubic equation means first root, second root, third root, all you have to add, then answer you have to write. Okay. Let us proceed step by step. Why? Because this is, even though they have given, this is also a little bit moderate question only, not easy question. Okay. Let us proceed further then. You see, now x is multiplying identity matrix means here x will come, that we know very well. Let me write this. You see, 2 2 1 1 3 1 1 2 2 a, let that this is a minus, directly send x inside, x 0 0 0 x 0 0 0 x equal to, okay. Fortunately no multiplication, only subtraction, directly you can do it. Okay, see 2 minus x, write down 2 minus x, 2 minus 0 2, 1 minus 0 1, 1 minus 0 1, 3 minus x, 1 minus 0, 1 minus 0, 2 minus 0, 2 minus x. Okay. See this, you can take as what we can say determinant. Now I am taking it as a determinant. Why? Because I want to find a determinant for checking singularity. Okay. See, rather than matrix symbol, I have made it a determinant. Why? Because I want to make it as a singular matrix, singularity. Okay. See, now we have to find this value of this. You see how I am finding delta, determinant delta. See, plus 2 minus x into AD minus BC. See, 3 minus x into 2 minus x. Okay, minus 2. But this should be under bracket. You see, I have not written plus again. Shall I write plus? Why? Because the first one is plus. Next you take 2, minus 2. Okay, minus 2. You close this. 2 minus x minus 1. Again plus 1. Okay, plus 1. 2 minus 3 minus x. Is it okay? Yes. Proceed further then. That is equal to this outside, let it be like this only, but inside first you solve. You see, first you have to multiply these two, then only you have to subtract. Okay, don't forget. See, 3 into 2, 6. 6 minus 3x minus 2x. Once for all I am writing. You see, minus 3x minus 2x minus 5x. Okay. Afterwards plus x square. Okay. See, shall I write directly minus 2? Yes. Now you close. Why? Because see, now you can multiply this. Afterwards you see 6 minus 2 also you have to do. Let it be like this. Okay. Now you see minus 2. Now see, this is not a multiplication. Who says 2 minus 1, 1 minus x. That's all. 2 into 1 minus x. Is it okay? 2 minus 1, 1 minus x. 1 minus x. Okay. Plus 1 you need not write. Minus of minus plus x 2 minus 3 minus 1, x minus 1. Okay. Proceed further then. You see, here 6 minus 2, 4 is there. 2 minus x into x square minus 5x plus 4. First you have to multiply this, then only you can do something. You see, minus plus 2x shall I write? 2x minus 2. What we call 2 into 1 minus 2 plus x minus 1. Okay? Yes, sir. Then go for, now this is okay, 2x plus x, 3x minus 3 we can write afterwards. But here you do something. Why? Because here the space is not enough. That is why I am continuing here only. You see, now 2x square minus 10x plus 8 minus x cube plus 5x square minus 4x. Okay, you see 2x plus x plus 3x minus 3. Now you can continue here. Why? Because you see, minus x cube will be bigger. First you write minus x cube. See, because singularity they are mentioning, afterwards we will make it equal to 0. Then that is going to become an equation. Minus x cube, right, first. Okay, now go for x square. 2x square, 5x square, 7x square, plus 7x square. Then go for x. Minus 10x, minus 4x, minus 14x plus 3x, minus 11x. Now go for constant. 8 minus 3 plus 5 equal to 0 because singular. Okay, write down. Now what will be the final equation? Shall I multiply with minus 1? Why? Because x cube I want to take as plus. If I multiply with minus 1 both sides, that the equation is going to become like this. You see, x cube minus 7x square plus 11x minus 5 equal to 0. Okay, now you have to solve this. 3 roots will come because it is a cubic equation. Cube, okay, power 3, power 2, power 1, power 0. Okay. See what I want to do. I want to remove the question. Question is not required then. We have to solve this equation. Then we are going to get 3 roots. 3 roots you have to add sum. Okay. Let me what we can say. Remove the question. And even singularity also I can remove. Not required singularity. Okay. 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 See. How to find the cubic equation root? Why? Because this is not easy for taking common. X square, even if you take common also, but here these are not going to match. If you take x square common, if these are going to match, then you can take in that formula. Or else what you have to go? Synthetic method. Formula you have to go. First of all, trial and error, you substitute any one number. Naturally what we are going to substitute to plus 1, minus 1, plus 2, minus 2, plus 3, minus 3. Within these 6 numbers, one root is going to come. Naturally it should come. Okay, let me try. One root. Afterwards we have to go for synthetic method. You see, at x is equal to 1, I am substituting 1. 1 cube is 1 minus 7 into 1 square 7 plus 11 into 1 11 minus 5 equal to, you see, minus 7 minus 5 minus 12, 11 plus 1 plus 12. 12 minus 12 equal to 0. That means LHS is equal to RHS. That means x is equal to 1 is one root. See, this root I have to consider. X is equal to 1. Okay, I am boxing it. Okay, now go for remaining roots. Try for remaining roots. But synthetic method you have to do. See, synthetic method how I am doing. Coefficients I am writing. You see, here coefficient is 1. 1 minus 7 plus 11 minus 5. Okay, 1, 2, 3, 4. Okay. Now this you have to do with 1. 1 has come. Okay. 1 into 0. 0. 1 plus 0, 1. 1 into 1, 1. Minus 7 plus 1, minus 6. 1 into minus 6, minus 6. 11 minus 6 plus 5. 1 into 5, 5. 0. If you add minus 1, see, in the synthetic method, first we have to take 1 into 0. Last automatically it should come 0. Then only your process is correct. See, what are these? These are nothing but, you see, 0 you avoid, x to the power of 0, x to the power of 1, x to the power of 2. That means, see, now it has become quadratic equation. Okay? Coefficients are these. You see, 1x square means x square minus 6x plus 5 equal to 0. This quadratic equation, if you solve, we are going to get 2 more roots. One root already you are having. All you have to add. Okay. Okay, see, 1 into 5, 5. Factorization I am trying. And the minus 6 has to come. You see what I am doing? Minus 5 into minus 1 is plus 5. Minus 1 minus 5 minus 6. Okay, shall I take? Yes. Proceed further then. You see, x square minus 5x minus x plus 5 equal to 0, comma. I am doing this rough calculation then. Okay. Then x square. No. See, both x is common. X, if you take common, x minus 5 will be there. Again, you have to take x minus 5 only, equal to 0. You have to keep. You see, minus x has to come, means you put minus 1. Okay? Now proceed further. See, x minus 1 into x minus 5 is equal to 0. X is equal to 1, x is equal to 5. And already x is equal to 1 has come. Also x is equal to 1. Even though x is equal to 1 has come, again you have to take this one. That means total sum of roots out. Sum of roots is equal to 1 plus 5 plus 1, that is equal to 7. This will be your answer. Fortunately, for these answers, 6 they have not given. If 6 they give, several students they are going to do mistake. Why? Because 1 and 1 both are same. That is why they will take 5 plus 1, 6. 6 in answer they have not given. They have given 7 only. Okay? Let us go for next question. Okay, see question number 15. Determinant they have given. We have to find the value of this determinant. That means delta I have to find. This question is asked in Eamcet 2004. You see, 1990, 91, 92, 1991, 1992, 1993, 1992, 1993, 1994. How we are going to solve this question? Can we take 1990 into this multiplication minus this one and minus this one? Like that are we going to do? No, you go for elimination method. Okay? Elimination method you apply. You see, logic is here 91 minus 0. 1 minus 0, 1, 2 minus 1, 1, 3 minus 2, 1. That means see 1 is going to appear. 2 minus 1, 1, 3 minus 2, 1, 4 minus 3, 1. That means what you are going to do? You are going to change R2. See what I am writing. See, R2 we are changing. Okay, what we are changing? R2 minus R1. Okay. Then R3 we are changing. What we are changing? R3 minus R2. Okay. See, is there any change in R1? No. Then you first copy R1. That is equal to R1 will be 1990, 1991, 1992. Okay. See, 1991 minus 1991, 1992 minus 1991, 1. 1993 minus 1992, 1. 1992 minus 1991, 1. 1993 minus 1992, 1. 1994 minus 1993 is 1. Okay, now see, directly shall I write 0. Why? Because we have got one theory. Theory or what can say theorem. If elements of 2 rows are same, all elements of 2 rows are same or 2 columns are same, the value is 0. Why? Because you see, 1990 into 1 minus 1, 0. Okay. 1991 minus 1991 into 1 minus 1, 0. 1992 into 1 minus 1, 0. That means 0 it is going to happen. Okay. This is the answer for this question. Okay. Now what we do? We stop this class and we will continue in the next class. Okay. Thank you very much.